Hello and welcome to this presentation of SGM 3D. My name is George Decker-Mention and I am the founder and president of Spatial Thinking. Today I'm going to give you an overview of this application as an interactive tool for teachers to present some concepts of space geometry and measurement. This application may be presented as seen here or in stereoscopic 3D. In this first module we can generate abstract mathematical solids from real-world objects, which contextualizes the study by making connections to the everyday world. We are able to interact with solids using a highly intuitive interface, which enables us to position, reorient, and even scale the objects as desired. One of the objectives of this module is to identify faces, edges, and vertices of polyhedra like the cube. In addition to identifying each of these parts, the teacher may choose to count them. And depending on grade level, a teacher may also choose to discuss the relationship between the number of vertices, edges, and faces of polyhedra and perhaps introduce Euler's identity. Next, we will take a look at solids and their nets. Nets are very useful in making the transition from two-dimensional figures to three-dimensional solids. Unlike traditional presentations, we are able to see nets in space. This makes the transition from two-dimensional thinking to three-dimensional thinking much easier. Also, unlike flat presentations, the interactivity of these solids provide high instructional value. And multiplying all of this interactivity with the many nets that are available makes this module quite comprehensive. Ultimately, our goal here is for students to connect the net with its corresponding solid. To that end, we may fold a single face or multiple faces, reorient or reposition the object, ask interesting questions like which face would be opposite the blue one. We may give some hints, such as showing the vertices, showing the edges. Finally, we are able to fold or unfold all of the faces simultaneously. Unlike video animations, being in full control of each of these objects gives the teacher and student a large number of permutations. And through mental reconstruction, a student will exercise his or her spatial thinking abilities and ultimately be able to reproduce the visuals mentally and at will when working on real-world applications. Building on our discussion of nets, let's take a look at how to find the surface area of a right regular pyramid. The Common Core Standards for Math states that students should be able to give informal arguments for the formula for the surface area of a pyramid. In addition to the interactivity for manipulating the pyramid's position, orientation, size, and so forth, we help motivate discussions about the relationships between the solid, its corresponding net, and ultimately to the formula that gives the surface area. As before, teachers and students are invited to pose and discuss interesting questions in their quests to help students understand the ideas behind formula for the surface area. Next, we are going to look at the volume of a rectangular prism. A rich understanding of a mathematical concept lies in looking at the same thing from different points of view. Typically, there are several ways for defining volume. One way to define volume is to talk about the number of unit cubes a solid can contain. In the case of a prism, we can leverage the three key measures, the length, width, and height, to help acquaint students with three-dimensional space. These three measures also happen to be intimately related to volume. Finally, making the connection between the total number of unit cubes, the actual rectangular prism, together with the length, width, and height, and its connection to volume, helps students discover the facts behind the volume of a rectangular prism. In this module, we are able to help students apply the skills and concepts they have acquired and/or discovered to real-world problems. This gives students an opportunity to immerse themselves in a virtual world and to relate mathematics to everyday objects, which makes mathematics more approachable, engaging, and even fun. Take some time to look over the ancillary materials accompanying this application. These include sample lesson plans and descriptions of each module. PowerPoint presentations accompany all the modules. These are linked to practice exercises for students to work through during classroom discussion, as well as formative assessments, giving students an opportunity to demonstrate their understanding. Thank you.